What's up, Algebra 1? Mr. Catlin here with your help for your cool down on Algebra Lesson 4 here in Unit 6. We're starting to compare quadratic versus exponential functions. We have a 5x squared and a 2 to the x power. Real quick, you need to be able to look at them now and know the difference between the two. This one we know is quadratic because of the square. And this one right here we know is exponential because of the variable in the exponents, right? Now, exponentials can vary based upon the base being different numbers and having a different growth factor, but quadratics are always going to have a 2 in the exponent. The numbers in front might change. There might be some things added or taken away, but they're always going to have that general square happening to them. So Tyler is completing this table for x values of these two expressions. Okay, 5x squared and 2 to the x power, plugging in 1, plugging in 2, plugging in 3, plugging in 4. And we notice this type of growth, 5, 20, 45, 80 for the 5x squared. And the double is doubling, 2, 4, 8, 16. The next will be 32. And so looking at this table that he's made, he's come to the conclusion that 5x squared will always take larger values than 2 to the x power. So he's saying that these will always be larger than these no matter what the x is. Do you agree? Explain or show your reasoning. Well, we got to be careful not to fall into this trap like Tyler has done. Let me show you the graph of these two because some of you might even go to the graph of it. Tyler might have even made the graph himself. If you make the graph of this, the red one is 5x squared, which looks like as we get bigger, it's beating the blue. It's higher, right? And the blue one looks like it's getting beat and it's not going to catch up, right? But if you actually widen the window out on this and you look at it change, let me move my ugly mug over here. If we change the window of this and we actually see how high this is really getting on the y-axis because we're getting cut off, let's change this to maybe be about, I don't know, let's go to like 200. Right? If you go up to 200, you'll start to notice, blue is starting to catch it a little bit. You might have to go a little further than 200, obviously, to see when it catches it. So let's broaden this out even further, and let's take it to 300 and see what happens. We're getting even closer. Maybe we need to go to 500 and see what happens. Here we go. So it looks like the quadratic is going to win, right? If you look in the early stages of the function. But if you carry this out to higher x's, like around 8, 9, 10, you start to notice that there's a point right here, actually at 8.495, where they are equal to the same output of 360 point whatever that is. And then after that, the blue starts to win. And from that point on, the exponent is just going to kick the tail off the quadratic because it's growing with a common growth factor of 2 every time. And as we learned about quadratics today, their growth factor gets smaller as it gets bigger. So let's go back to our actual homework page and let's answer this question now that we have a better idea of what the graph looks like as we expanded the window out a little bit. Move my face over here all. Do we agree with Tyler? No, we don't. And we need to show our reasoning. Okay, so I'm going to show it here instead of explain it. I'm going to show and prove that it's not going to be the same by actually making the chart a little bit further. Okay, so what I'm going to do is I'm going to extend his chart. I'm going to use this over here. All right, so I'm going to extend his chart down and I'm going to extend it over. What is going on with this? This is going really slow. It's kind of annoying. Sorry about that, guys. Let me see if I can just draw. Maybe it'll let me draw still. Wow, it's really delayed. Sorry, guys. Okay, so let me draw this table extended. Maybe if everything would stop acting really strange. There we go. Okay, let's go to the 5th, 6th, 7th, and 8th terms of this. All right, if we kept going and we found out what the outputs for these functions were when x was 5, 6, 7, 8, and we might have to go to 9 to really prove the point and nail it home. So we'll include that one on there too. Okay, so whenever we put these into the table for these, I'm going to actually use Desmos for this because I think it'll make it go faster, and hopefully when I go back to that page, it won't be frozen again. All right, I'm going to take this one and I'm going to change it into a table. And remember that we wanted 5, 6, 7, 8, 9. We'll go all up to 10 just for a good measure. And then we'll do the same thing with this one. Let's change it to a table. And we'll make it 5, 6, 7, 8, 9. Oh, the one down at the bottom for the 5x squared, we got 5 is 125, 6 is 180. So 5 is 125. 125. 6 was 180. 7 was 245 and then 320. 245 and 320. And I guess we'll do the 9 since it's already on there. It's not going to hurt. The 9 turns out to be 405. So 405. Now, the double, we can do that one in our head. 16 doubled gives us 32. This doubled gives us 64. This double gives us 128. This one double gives us 256. And that last double gives us 512. And this is the step where we see it overtake it. It took 9 x values of increase for it to get bigger, but we don't agree with him because it just takes more increase of the x for that double exponential to really surpass it. And you don't even see it in the window whenever it's really tight in close. But whenever you really start to make this thing get bigger and you plug in bigger x values for x squared into the x power, it catches it, and then it's just going to take off. The next one for that one is going to be over 1,000, whereas the 10th one for the other turns out to be like only 500. Like it's already doubled its size at this point, and it only took 10 values of x. Imagine where it's going to be after 100 or 1,000. It's going to be crazy. So quadratics, they might look like they win for a time, as you can see here, but there's a point when these exponentials are they just grow so fast. They grow so fast, especially as those x values get bigger and bigger and bigger. And so that's what we kind of looked at today. That's what we studied today, and that's really all you need to prove your point of why we don't agree with them always being bigger. We could say after 9, when x is greater than 9. Here, let's write that down. When x is greater than 9, 2 to the x is always larger. There we go. And we're done. See you guys later.